I was thinking about showing you some demo, but then you know what happens when you have to get something done very, very fast. Well, it doesn't. And so today we don't have the full demo. One issue is also because we are using that current version, we've been developing it with the customer, so we don't have the rights yet to open source it. We are still having negotiations, but when we get the rights, then you will get some free software. So today I will tell you about some CRDs and in action. So how to use Kubernetes as state storage for your extensions. And now you don't. How many you know already what is the CRD? Because it will really. Oh, that's good because actually Lucas wrote what's the real meaning, like, because it's abbreviation. And I said that no, don't. You will waste my joke because I have few things like if you okay. Well, it's not even funny. Now when I say it, it's not funny at all. But really, if you write CRD into the Google or something, you will find what it is. It's at least one disease, but I found some other thing. So, yeah, I'm Teemu, and I come from a company called Emblica. I always say that we are a hard tech company, so because we are not doing JavaScript front-end. But I don't say that's not hard. It's usually very, very hard to fiddle one button on the right place. So whoever you are doing that, I feel your pain. We're super small, though. Last time when I was presenting in this Kubernetes meetup, we were 5. Now we're 8, so it's pretty good. Actually, there is 2, Johanna and Robert. Show your hands here from us. So. Actually, both of them are kind of new, so it's it's good. We're still hiring, though. So we've been doing with some Finnish clients mostly, some startups and some bigger enterprises too. We're doing some big data stuff, something related to IoT thingies, something related to video, and something related to new fancy machine learning stuff. However, now I'm going to explain what is the CRD. So it's math. It's just this one function, and no, it's not short function. Though Wikipedia says it's actually a long word, and it means custom resource definition. So it's a Kubernetes feature to provide custom APIs, custom REST APIs for you, and it has a few features on it, so it's not just some custom API, but it's something that you can define, actually even pretty strict way. So that way you can have your data consistent and most of the Kubernetes tools that are actually automatically generated from the Kubernetes API manifest can use them straight away. So you can create API that you can use with the tools that are already available, such as your kubectl tool. This is how it looks like. So this one is the custom resource definition. So this defines what kind your API will be. And here is, as you can see, it's actually lots of things about naming. So there is, for example, now I'm creating some new called cron tabs. And I'm just telling the Kubernetes what is the namespace, what is the version. I'm telling that how I should call it at the APIs or somewhere else at the tools. Then when I push it, I can have that kind of API. Well, that's sad. There is line. Okay. Well, even though it's URL. Oh, okay. Well, that's good. Well, yeah. So after that, you can access it even with your web browser. It works like normal JSON REST API, but it comes from the Kubernetes API. So then I can create REST objects even with kubectl, because kubectl works straight away with the CRDs. Lucas looks like, huh? Am I saying something not right? Okay, cool. Yeah, I was really worried. Okay, so after that you can use your kubectl and some other libraries that are accessing the Kubernetes API. So all the API clients that are fully compatible with Kubernetes, they work straight away with that. And then you can get your objects on, you can list, or you can even filter them in some way. So it's essentially well, some kind of validated key value store inside of Kubernetes. And yeah, you can query like what is in of that and get its YAML presentation or JSON representation. And
yeah,
that's...
You can define your own schema as well.
Yeah, you can define your own schema, yeah. And that's the little bit validation, because there is not a lot of options, but it's JSON schema, so it's still possible. Well, that's so cool, because now I can actually, I don't need database, I can use Kubernetes for that. So everybody of you who've been always thinking like, what kind of database to use for my blog, use Kubernetes. Or no. Actually there is a list like when to use it or when to create a new API. And because of this slide, I think I will need to make new pull request for one additional line. So if you're making a blog, please prefer standalone API. And if your custom resource really is related to Kubernetes or related for managing the cluster resources, then it's probably okay for using that. So what we did with that? Well, let's go forward. We'll see. So this is one of our customer projects. It's a little bit simplified version and it's a little bit out of context, but it works. So we will have, let's say, only 2 systems, but in reality we will have more systems. And those systems will get, for example, hourly dumps of something very important data. And we want to have Kubernetes jobs running on top of that. You will have hourly dumps, and we want to run some pods, some jobs, on top of the Kubernetes to actually process them. And there are some jobs that depends on other jobs. And this is something that you currently can't do with Kubernetes on its own. So you can't set some jobs that some job is depending on some other job or to finish it. So, of course, then you need to build something. In the open source world, there is actually already workflow managers for the big data stuff and all that kind of stuff. For example, Azkaban or Airflow is pretty good alternatives for that. But the problem with those are that they're not invented in the time of Kubernetes. So they're defaulting that you don't have any infrastructure for scheduling your jobs or running them on different machines, nor they support Docker containers usually. For the Airflow, there will be support in some point for Docker containers, but that doesn't still mean that we can run on stuff on Kubernetes. I saw a few pull requests for a few GitHub issues regarding that, but it was not ready yet, and we would like to have it now. So the problem with the job scheduling, like on the order, is that we have to solve direct acyclic graph. So we need to know the order of when we run each task, so we can have them like so that if something needs. For example, we have one here, let's say, here we go. So if we want to have the ML model trained, we need to have a whole data set. And those are different pods. So these are different Kubernetes resources, and we need to get them first. So that's why we need to also calculate the order. And that's topological order of the directed acyclic graph. So oh, that's hard. Hard to say in English. Well, after that, we will get some we will get the order, and we can also see that what's depending on what, so we can probably even run some things in the same time simultaneously. And for the solver part, it's very easy, and the Kubernetes actually solves the scheduling issue, so there is not so much to implement for the full working workflow manager. Oh yeah, this was the last idea. Like, why not use Kubernetes then if we have the problem? So we created something. It's called Dagger, and it actually solves the problem that how we can use Kubernetes jobs to first easily move the state between those jobs and run them in the correct order. We are using the CRDs because they work as a database. We are using them to store the workflow manifests. So those manifests are actually defining what kind of tasks we have and in which order. Or actually, they don't decide which order they define what depends on what. Then we also use CRDs for storing the workflow state. So each time some job completes, the Dagger daemon itself will write to the CRD that now this task is done, and we can continue calculating what's next. Also, if something fails, then it can force to retry. But actually, it works pretty good way with just Kubernetes jobs. They have some kind of error management too. And then, well, for the Dagger, so for your own application, if you want to build something on top of this CRDs, you just need to take care of the data coming. And for the Kubernetes CRD, it offers you the watchers. So you can watch some resource, and when it updates, it can react immediately. So you don't need to poll the API. Though we first started with polling, of course, because watching is too complicated for the starters. Now it's still polling. Okay, so it watches the jobs and updates the workflow state accordingly for that. This is how it looks like, and now I don't know if you can really see it, but this is how the manifest looks like. So this is pretty random manifest because there is some parts that are actually working and some parts that are not. But the very important part is the tasks. So here we have tasks, for example, load Kubernetes homepage that actually just runs in some busybox, some vget, and it gets the Kubernetes IO index HTML. And then after that, it will touch some file. So our Dagger will have also some sidekick containers watching the state. So actually, what happens inside of the Dagger container, there will be 3 images: one for the work, one for the state loader, so it will load some previous state if there is any, or some parameters to use in the actual work container. And after that, we have state saver container that actually takes the state and pushes it back to the object storage so it can be used in next stage. So the only requirement for the work container is that it will in some point touch some file. And I hope in the future we will have good support for the Kubernetes API to actually support the case that some container will get done or will get shut down successfully, so we can see that without the state file. So what happens here is that this one, which is very stupid name also, well, this one depends on the load Kubernetes homepage. So it doesn't run before the Kubernetes homepage is actually loaded. And if it fails, then it still waits for it to get through before it continues. And after it's ready, it will also touch the state ready command, the file. And then when we have the workflow, the only thing we need is to actually launch the workflow. And we use another CRD for that. Its name is Dagger Run. And this can be launched just with the kubectl tool. So we have here, for example, some input parameters we would like to input for the workflow. Or then we actually implemented some webhook endpoint, so you can ping on some webhook endpoint and it will automatically create this resource for launching the job. And this little resource actually changes after you submit it. The Dagger will continue to updating this resource and update the state of the workflow here. So now we don't have, but we could have some fancy UI for seeing how it's going. So here's one more time. User can create a Dagger manifest and launch it multiple times with the Dagger run. And after that, the Dagger itself will see the changes in Dagger manifests and Dagger runs, and it will create jobs accordingly for those. We're open sourcing Dagger soon when we can, so wait for it. Okay, thank you. If you have any questions, please. Oh, somebody's going to applaud. Okay. Yeah, so any questions about CRDs or Dagger or anything? Okay.
Any estimation on the date of the open source?
Okay, that means you're interested. No, not yet, not yet. I think in a few weeks, in a couple of weeks, but I'm not sure yet. Like the open sourcing, it is pretty much the second objective. So, but it's actually running already, so it's some kind ready. But probably the code, there is some. For example, first we started it with just Kubernetes kubectl. So we actually from our code we just used the kubectl straight away. So we didn't have any API library because that's actually very easy when you output just JSON. So we need to replace those before we open source to use the real library. And also what I would like that it would automatically, like I don't want to just implement new client on top of the REST APIs, but I want it to actually automatically discover the versions of the API. Then some more fault tolerance is actually needed before the launch. But yep, it won't be ready in that that mean when we launch it. So it's if somebody is interested in contributing it, that's good to hear. Anything else? Okay, I have one more thing for you. Actually, it's not related for Kubernetes anyway, but it's related for what we do. One very stupid thing we do is push-ups. So do sports and use some machine learning to count them. Thank you.